Dear students, today we'll discuss about accuracy, precision and errors in measurements. First come to accuracy. Accuracy, it refers to the closeness of the measured value to the true value of a quantity. It refers to the closeness of the measured value to the true value of the quantity. For example, it is a line. Suppose the true length of this line is 10.5 centimeter. If you are asked to measure the length of this line by using standard scale, you know the standard scale has the least count of 0.1 centimeter. When you measure, let your measurement be 10.6 centimeter. If another student is asked to measure the length of this same line by using the same scale, suppose his measurement is 10.8 centimeter. Now, which measured value is more accurate? Now you compare this with this and then this with this. What is the difference? For this measured value, it is 0.1 centimeter. 10.6 minus 10.5, that is 0.1 centimeter. Similarly, the difference between this measured value and this true value is 0.3 centimeter. Then which measured value is more closer? This measured value than this measured value. That means this measured value is more accurate than this measured value. It gives more accuracy. Then come to precision. What is precision? It refers to the limit or resolution to which the quantity is measured. What do we mean by limit or resolution to which the quantity is measured? So this limit or resolution depends upon the least count of the measuring instrument. Suppose you are asked to measure the length of this pen. If standard scale is provided to you, standard scale, you know the standard scale has the least count 0.1 centimeter. If vernier calipers is provided, vernier calipers, then its least count is 0.01 centimeter. When you measure the length of this pen by using standard scale, suppose your measurement comes as 10.2 centimeter. By using standard scale, you cannot measure up to second decimal place in centimeter. You can measure up to first decimal place because its least count is 0.1 centimeter. If you use vernier calipers, then you can measure whether it is 10.21 centimeter or 10.22 centimeter. That means you can measure up to second decimal place by using vernier calipers because its least count is 0.01 centimeter. But you cannot measure 10.212 centimeter or 10.213 centimeter because its least count is 0.01 centimeter. If the least count be 0.001 centimeter, then you can measure up to third decimal place. That means this measurements depends upon the least counts. If the least count is 0.001 centimeter, then you can measure 10.212 centimeter or 10.213 centimeter. That means these measurements depend upon the least counts. Less is the least count, more is the precision. You remember, very important sentence. Less is the least count, more is the precision. That means this least count gives more precise result. Now come to error. Errors in measurements physics is the science of measurement. There are lots of experiments you have to do in physics. In experiments you are measuring. While measuring, you may not get the accurate value, the true value of the quantity. You will get the measured value that is closer to the true value. That measured value and true value, there is a difference. There is a gap. That gap or that difference is called as the error. So error is the difference between the measured value and the true value. Error is equal to measured value minus true value. Now come to types of errors. First come to systematic errors. Systematic errors, these errors occur in one direction. These errors occur in one direction. In one direction means either the measured value is more than the true value, means measured value is always more than the true value. If it is less, always the measured value is less than the true value. These systematic errors occur in one direction, you remember it. And you remember, the sources of systematic errors are known. These are the errors due to known causes. Cause of systematic error is known. Then come to what are the causes or the sources of systematic errors. Sources of systematic errors. Number one, instrumental error. Number two, imperfection in experimental techniques. Number three, personal error. Number four, change in external conditions. Now come to instrumental error. Instrumental error, that is due to the inbuilt defect in measuring instrument or the imperfect design or the calibration of the measuring instrument. For example, For your vernier calipers, there are two scales. One is vernier scale, other one is your main scale. To get the accurate result, the vernier 0 should coincide with main scale 0 when the two lower edges are in contact. If vernier 0 doesn't coincide with main scale 0, then 0 error comes. Either positive 0 error or negative 0 error. Always you will get the measured value in one direction. That 0 error is the one example of instrumental error. Now come to imperfection in experimental techniques. For example, in calorimetric experiment, the heat, there should not be any loss of heat, but due to the limitations in experimental arrangement, some heat is lost due to radiation. So you will get some error. So that error falls in this category. So this error, imperfection in experimental technique, is due to limitations in experimental arrangement. Now come to personal error, that is due to individual bias, lack of proper setting of the apparatus, or the lack of proper setting of the your instruments, or individual carelessness in taking measurements. For example, your parallax. In parallax, some persons have the parallax, means one-sided view. That means either he sees or he measures the values more than the true value or less than the true value. That falls in this category. That is your personal error. That is due to individual bias, lack of proper setting of the apparatus, or individual carelessness. Now come to change in external conditions. Also, you are getting some error due to change in external conditions like pressure, temperature, wind, etc. These are the errors which come in systematic error. Now come to random errors. Number 2, random errors. Random errors are due to unknown causes. Unknown causes. The cause of random error is unknown. That comes irregularly or randomly. Sometimes the measured value is more than the true value, and sometimes it is less than the true value. That falls randomly, irregularly. You don't know what is the cause of the random error. Now come to list count error. Number 3, list count error. This error arises due to resolution of the measuring instrument. Already told, your standard scale, vernier calipers, and screw gauge of speedometer. If list count is less, then you can measure very closer to the true value. That happens if list count is more, you will not get the measurement closer to the true value. These errors are due to the resolution or the limit of the instrument. It is your least count error. Now come to minimization of random errors. While doing experiments, some errors come due to unknown causes. To eliminate the error, what will we do? Instead of taking one observation, we have to take a number of observations. Suppose A1, A2 to A are the n measurements of the quantity. Then the arithmetic mean can be considered as the true value of the quantity. What will we do to eliminate random errors? We have to take a number of observations instead of one observation. We have to take these readings or these measurements. If A1, A2 to An are the n measurements of the quantity, then the arithmetic mean is A1 plus A2 up to An by n. This A bar is considered as the true value of the quantity. Now come to absolute error. Absolute error, relative error, and percentage error. Absolute error, first come to absolute error. Absolute error in the measurement is the magnitude of difference between the measured value and the true value. It is the magnitude of difference between measured value and true value. For example, if A1, A2 up to An are the n measurements, then errors in measurements in first measurement error is A1 minus true value, that is the arithmetic mean A bar. In second measurement error is A2 minus A bar. In nth measurement error is An minus A bar. If the measured value is more than the true value, then the error is positive. If the measured value is less than the true value, then the error is negative. That means errors may be positive or may be negative. But absolute error is the magnitude. That means that is always positive. That means absolute error in the first measurement is delta A1 magnitude A1 minus A bar mod. Similarly, the absolute error in the second measurement, that is A2 minus A bar. In nth measurement, delta N bar An minus A bar. These are the absolute errors in first measurement, second measurement, and nth measurement respectively. Now come to mean absolute error. Mean absolute error It is the arithmetic mean of absolute errors of all the measurements. That is delta A bar is equal to delta A1 plus delta A2 plus delta AN divided by n. These are the absolute errors. The arithmetic mean of all absolute errors is called as mean absolute error. Any measurement can be expressed as A bar plus minus delta A bar. That means before plus minus, that is the true value, after plus minus, that is the error. If error is delta A bar, then the measured value is more than the true value by delta A bar or less than the true value by delta A bar. So any measurement can be expressed as A bar plus minus delta A bar. Now come to relative error or fractional error or fractional error. You remember relative error del AR, that the ratio of mean absolute error and the true value of the quantity. Relative error is defined as the ratio of mean absolute error to the true value of the quantity. It is also called as it is a fraction, it is called as fractional error. Now come to percentage error. Percentage error, when the relative error is expressed in percentage, then it is called as percentage error. That is del AP, that is delta A bar by A bar into 100. It is your percentage error. In the next class, we will discuss about the arithmetic operations of the errors.